So I'm going to have a set of accelerations when it's 4 meters per second squared speeding up. And then when it hits its brakes, I'm going to have an acceleration of what? -6 meters per second squared. I put a little dashed line there. I would if I were you. Over here, I'm going to just deal with things that have to do with 4 acceleration. On this side of the line, I'm going to deal with stuff that has -6. I'm going to keep them separated at all times as best I can. So, Ms. Kirkland, let's start the first part of the problem. It says Bob initially accelerates at rest. Initially at rest. So what's the initial velocity? 0. So initial velocity is equal to 0 in this land. I accelerate my car at 4 meters per second squared. We already got that written down for 9 seconds. So my time is 9 seconds. He then slams on his brakes. Okay, so that's the first realm. And then 9.6 till he comes to rest. What do I know about rest then? And what does that mean? Which velocity? Final or initial? Final. So his final velocity over here is 0. How far do you travel and how much time did it take to do it? So I need how far you traveled in both times, right? So let's figure out how far do you travel on this side. Let's go. D equals 1/2. Oh, you're plugging things in already. You're a beast. Got it. I got it. All right, keep it up. 4 9 squared plus what's my initial velocity? 0 times 9. Put it in my calculator. You got 162 meters. Great. Now I need to know the distance over here. So how do I find the distance over here? What equation am I going to use, Ms. Kirkland? Distance, right? Because I want to know distance, displacement. 1/2 AT squared plus V naught T. How far did he go? We don't know. 1/2, what's my acceleration? -6 times the time, how much time? We don't know. Uh-oh. Okay, so we don't have much time. That's troubling because now I got 2 unknowns. What's my initial velocity over here? Oh, man. I got 3 unknowns. Yes, ma'am?
I think if we find the final velocity for the first part of the trip,
that would
be an initial velocity for the second.
Ms. Kirkland, does that make sense? I was going to make you try to figure that out in a second. I need to know the initial velocity. It's one thing they need to know, and that would be the final velocity over here, would it not? So now I got to go back into this side of the problem and go V equals V naught plus AT. That's my final velocity equation. Final velocity is, I don't know. If I knew that, I wouldn't be doing this problem. What's the initial velocity in the first part? 0. What's my acceleration? 4. How much time? 9. So what's my final velocity? 36, which becomes my initial velocity over here. So that fixes one of my problems, and I have D equals -3t squared plus 36t, and I did that really fast, so catch up to me. Good? Kirkland up to there? We need a little more time. Okay. I still need time or displacement. One of the two. I don't have either. What am I left with? I need to know how much time it takes to do what? Well, we did up here, we accelerated for 9 seconds, and now we're decelerating. So I want to know how much time it takes to do what? Decelerate to what?
0.
To 0, which is our final velocity, right? It's 0. We have a final velocity. We haven't used the final velocity equation. How do we do it? V equals V naught plus AT. I want to find the time it takes to stop, right? So final velocity is 0. Initial velocity is 36. Thank you. Missing it. What's my initial? So what's my acceleration? -6. How much time? Don't know, but that's why we're doing this one. So it's good that that's the only thing we're missing. So I move this target. -36 equals -6t. T must equal 6 seconds. All right, so what sets this in motion? 2 accelerations, 2 different sections. So I need to figure out how far I'm going to go to the second section. So I'm going to take the 6 and plug it in here and here, right? I should get my displacement. Put in my calculator. How about 108? Is that right? Well, somebody else got it. Feel much better about my answer. All right, so how far did he travel in total? Add the 2 displacements together and I get 270 meters. So 270 meters, how far he travels in total. And how much time did it take him? 9 seconds for the first part, 6 seconds for the second part, so I get 15 seconds. Agreed? Oh, yeah. And again, what triggered this strange method? I have 2 accelerations. If I have 2, 3, 4, 5 accelerations, I may have to break the problem into chunks and deal with each chunk separately so I can continue to use my equations. 2 reasons. For some of you, it might have taken much less time to do this, right? Because all you need is the height, and then when the thing goes there, you're done. The second reason, I can't tell you why this works until I give you a graph or teach you calculus. I'm not going to teach you calculus, so I have to give you a graph. And then the third reason is this problem right here, which we're not going to learn how to do this year other than use a graph. And then the fourth reason is we're going to do force times distance graphs, and I'm going to expect you to know that you have to find the area of the curve to find work. That's a way in the future. Don't sweat that one. So far, good? All right, flip this, don't flip this over. Try number 6, go. Pausing. Those of you who got on Friday, you're going to have to finish this other worksheet without much help. I'm going to ask the class as a whole to do those problems. That'll take you a while. It's only 6 problems. In physics class, if you only have 6 problems, it's a bad day. You want to have 10. 10 are much shorter than 6 usually. How many accelerations do I have in this problem? 2. So I'm going to set up this. Now be careful. That's not an simple question. You might have 3 or 4 or 7 accelerations, right? Probably no more than 3, but you could have more. Initial acceleration is 1.00 meters per second squared. Over here, I've got negative 3.00. You're responsible for the negative yourself, right? Slowing her down. So then initial velocity of 8 here. And that's about all. Oh, and final velocity of 0 over here. Right? I know the displacement here is 66 meters. So, rippling through the problem, I'm going to go d equals 1/2 at squared plus v naught t. The displacement 66 equals 1/2. 1 times time squared. Initial velocity is 8 times t. Solve that using the quadratic equation, right? 0 equals 0.5 t squared plus 8t minus 66. I get the time it takes to do it. Boom. Polynomial second degree going fast. 0.5, 8, negative 66. Boom, boom. I get 6 seconds. So it takes 6 seconds there. Now you just need to know how much time it takes over here, right? So I start off with, time to stop, right? So v equals v naught plus at. Final velocity is 0. Initial velocity, don't know it. Solve for the final velocity over here. It's your initial velocity over here. Plus -3 times time, and then you're done with this problem because they just asked how much time does it take. We don't need to know. Because all the question asks how much time, right? So if I solve for my velocity here and plug it in here, I'll get my time and I'm already done. Now, could I solve for distance? Yes. Once I have that information. Yes, ma'am. No. 3, 4. Sorry, 2, leave alone. You're done with that part. 2, 9 is it?
Yes.
That one I want you to do.
Even if we're going to be here.
If you're going to be here next time, do it anyways, because then we're going to go over in class. It'll be a little boring if you did it right, but then we're going to have to go through most of the problems.
First summary, question of the week, the back of 2-1, 4 and 3.
Yes.
And then 2-9.
2-9. Yep.
Oh, I didn't realize.
So 2-9, the back of what you gave us. The back of 2-2.